Okay, good morning everybody. We're going to start. Before we get started on the lecture though, I want to remind you guys of a couple of things. First of all, I have office hours today from 11 to 1. Virtually, you can find the link on Blackboard. So, a lot of students were really confused by the chain rule. We spent an extra day on it. I still sense that there's some lingering trouble with the chain rule going on. So if you feel like you'd like to become a little bit more comfortable than you are right now, come to office hours. Okay, the next thing that I want to talk about, or announce, I guess, is we're now 1 day behind on the schedule. So that means that our, quote, review day will instead be a catch-up day. Okay, so unlike last time, we won't have a review for the exam during class. Okay, what I will do is I'll post a video that's kind of like what I did for the last review, where I went through and said, here's what you need to know from this section, here's what you should know from this section, and so on and so forth. I think it's better to use class time to catch up than to do that anyways. So that's what we're going to do. And yeah, any questions? Y'all good with that plan? All right. As usual, I'll post like a practice exam, and I'll go through the practice exam and solve it on the YouTube page after I give you guys a few days to try it. And yeah, that'll be what we do. Okay, so last time we were going to do this note set, but we got kind of caught up on this chain rule problem here, and so we wound up spending the day going back over the chain rule. So what I'll do really quickly is remind you how we solved that problem, and then we'll do A together, and then we'll jump into the material for today. So what we learned last time was that this is actually a composition of three functions, right? It's a composition of three functions. Okay? The innermost function being x cubed, which is being plugged in for z in the function e to the z, which is being plugged in for y in the function square root of y. Okay, so three layers of functions, two total compositions. We're going to have to use the chain rule twice to do this derivative. So we could write it as like p of q of r of x, where r of x, our innermost function, is going to be what? What do we think the innermost function is here?
Is it x cubed?
It is x cubed. Very good. Thank you, Dylan. Okay. So we have r of x is x cubed. That's the innermost function. And so we should think about that function being plugged into some function q of, I don't know, we'll go x, y, and then z. Q of y equals some other function, and then we'll plug that thing in to the function p of z. So I kind of already said what these guys are going to be. Q of y is going to be this function e to the y. So if we just do q of r of x, so we just consider what's on the inside here, if we did q of r of x, we would get e to the x cubed, where we just replace that y by the function x cubed. Okay, so when I want to figure out what p is, I need to think of, okay, what is the function such that when I plug in e to the x cubed, I get square root of e to the x cubed. Okay, and that function is going to be the function square root of z. Okay? So we're kind of treating this whole q of r of x as our z. Okay, so if we want to go the safe route, what we can do is just go ahead and compute r prime of x. That's going to be 3x squared by the power rule. Q of y, we've done this several times. It's going to be e to the y. And p prime of z is going to be 1/2 times z to the negative 1/2, which is equal to 1 over 2 square root of z. Okay, and so we can kind of cordon this section off and say this is kind of like our pantry where we have all the ingredients that we need to go ahead and plug into our chain rule. Now, if I want to do the derivative of, remember that's what this ddx notation means, do the derivative of p of q of r of x what I should do first is the derivative of the outermost function and leave the inside completely alone. I'm going to leave q of r of x just like how it was. And now I should multiply by the derivative of the inside. But the inside is itself a composition of functions. So to do the derivative of q of r of x, I need to apply chain rule once again. So what should I multiply out here? In terms of q and r, yeah, Ashlyn?
Should it be q prime times rx?
It should be q prime of r of x. One more step. What's the last step here? Yeah, Ryan? Yeah, times r prime of x, where we multiplied out by the derivative again of the inner function. Okay, so 2 chain rules. Okay, so now we can just use our blue box here and plug things into the appropriate places and get our answer. I'm sort of running out of space. I'm going to move this and put it, uh-oh, I don't want to move that part. I'll tell you what, I'll just erase that. I'm going to move this kind of up here. And remember there's a little bit of a divider here. Okay, so if I want to go ahead and plug in now, I'll take this information that's on the right side of the red line and plug in. So first I should take the function p prime of z, that's 1 over 2 square root of z, and I should go ahead and just plug in q of r of x. So for that part I'm going to get 1 over 2 times the square root, and I'm going to replace z by the function q of r of x. So I'm going to take r of x, that's x cubed, I'll plug it in for y in the function e to the y, and then I'll take all of that and plug it in for z in this square root. So I'm going to get e to the x cubed here. All right, so now we should multiply by q prime of r of x. So q prime is just e to the y again. And if we plug in r to the r of x, we get e to the x cubed. And now I have to multiply lastly by r prime of x, which is 3x squared. Okay, so now that we've seen this problem solved a couple of times, let's have some thumbs. How are we feeling about it? Thumbs up for like, I'm starting to get the hang of this. Thumbs down for, this is still really confusing. Okay, I see a lot of thumbs up, some sideways. That's good. Okay, so that's how we do that. All right, like I said last time, as you get faster and faster with the chain rule and you become more familiar with it, you'll probably kind of drop this process of writing down all of these functions and giving them all names and then finding all their derivatives because it's a little bit tedious. Okay, and you'll just start to kind of recognize, okay, I have to do the derivative of the outermost function and then leave the inside alone and then multiply out and so on and so forth. Okay, great. We did this other warm-up problem last time, I believe, so we can go ahead and jump into the actual material of the lecture today, unless there are any lingering questions about the chain rule. Okay. Well, if you do have any questions and you're not speaking up, come to office hours and we'll get you on track. Okay, so today we're going to learn about two more rules. So we've already learned about all of these derivative rules involving polynomials, doing derivatives of constants times functions, sums of functions, compositions of functions. And now we're going to learn two more rules which have to do with products and quotients of functions. Okay, so a product of functions is if we take two functions and multiply them together. And a quotient of functions is if we take two functions and we divide them by each other. Okay, so what the product rule says is if I want to do the derivative of f of x times g of x. Okay, f of x times g of x. Well, the product rule is being covered last, I guess, because it's one of the more complicated rules. What would be really nice would be if this derivative was just, well, you take the derivative of f and multiply by the derivative of g. That would be convenient. And that's the sort of rule that we have for sums of derivatives or multiplication by constant, right? But in this case, we don't actually have that nice property. What we actually get is f prime of x times g of x plus regular f of x times g prime of x. Okay, so this is quite a bit different than what you might expect after learning the sum rule, okay? And this is going to just be another one of those formulas that you're going to need to commit to memory. Okay, so here's a couple ways of remembering it. You can try to memorize this formula that it goes f prime g plus fg prime. The product rule also has the convenience of the fact that we have a sum here. Okay, so if you wind up accidentally switching these two things up in the wrong order, that's okay, because, for example, we have the nice property for addition that 3 plus 6 is 9, but so is 6 plus 3, it's also 9. Okay, so if you get the two of these two things mixed up, it's no big deal. What you need to remember is that one of the terms we should do the derivative of one function and multiply by the other. And then the other term that we add, we should do the derivative of the other function and multiply by the one. Okay? So, in the first term, I do the derivative of the first function, leave the second one alone. The second term, I leave the first function alone, and I do the derivative of the second one. Okay, and we add these two things together, and that'll be our derivative of this product. Okay. So let's have an example of how this works. Much like the process with the chain rule, okay, my first kind of order of business here is to identify which functions are being multiplied together, okay? And when I want to split a product up, I want the two functions that I come up with to be functions that I know how to do the derivative of. Okay, so this, for example, x squared times e to the 2x, we could split it up in a number of ways. We could say that this is the function x times the function x e to the 2x. Or we could say it's the function x squared times the function e to the 2x. Those are two ways that we could have split it up. Okay, and what I want to point out is that our goal should be to split things up in a way where we know how to do the derivative of both of our pieces. Okay, in particular, I know how to do the derivative of x squared, and I know how to do the derivative of e to the 2x using my rules that I already have. Okay, so we're going to wind up doing it with this second method. The first method is not a great choice because although I know how to do the derivative of x, I still would need the product rule to be able to do the derivative of x e to the 2x. Okay, so we should split it up in a way where we split it up into the multiplication of two functions which we already know how to do the derivative of. Let me erase that stuff. Okay. So for the sake of the notation, I'm gonna rewrite this problem a little bit. We're gonna change this to an h here, okay? We're gonna call this h of x because I want my notation to be similar to what you guys see in the product rule for the first problem. So if I want to say that this is equal to f of x times g of x, where f and g are functions that I already know how to take the derivative of, then f of x should be the function x squared, and g of x should be the function e to the 2x. Okay, so the first step is to identify which functions are being multiplied. Similar to how the first step of the chain rule was to figure out which functions are being composed. The second step of the chain rule was find the derivative of those functions, and much like the chain rule, that's what we're going to do here. So the second step, we're going to find the derivative of these two functions. So f prime of x is going to be the derivative of x squared. We all know that should be 2x from the power rule. How about the derivative of g? Yes?
Wouldn't it be e to the 2x times 2?
Exactly right. It would be e to the 2x times 2. And what rules did you use?
The e to the kx.
Okay, e to the kx rule. That's good. E to the kx is also could be thought of as an application of the chain rule. Okay, so that's a good point. We could use the e to the kx rule and just use that one rule. We did learn that in class. Or we could also think of e to the 2x as a composition of functions, where the function 2x is being plugged into the function e to the z. So this 2 can be thought of as coming from the derivative of that 2x. Or it could be coming from the e to the kx rule. Okay, so two ways to do that derivative. Thank you, Alice. Okay, and now here's what we're going to do. This first term here, we should take the derivative of f and multiply that times regular g. Okay, so I'm going to draw this arrow here to say that we're going to multiply those two things together. And we get 2x times e to the power 2x. Okay, now I get a plus sign. And what the product rule says to do next is take regular f and multiply that by the derivative of g. So I'm going to draw a little arrow like this and make this kind of a crisscross pattern. Okay, so now what we're going to do is just take regular f, that's x squared, and I'll multiply it by the derivative of g prime, which is e to the 2x times 2, but I'm going to move that 2 to the front. That's usually how we write the constants, out at the front instead of in the back. Okay, and that's pretty much the simplest application of the product rule. Product of two functions we know how to do the derivative of. Instead of just taking their derivatives and multiplying them, we have to do this crisscross thing and sum. Are there any questions about the definition of the product rule or about this example? What do we think? Do we think this is easier or harder than the chain rule? Easier, okay. Yeah, I taught another section last night and they felt exactly the same as you guys did. So that's good. I think the product rule is easier as well. It's usually actually taught before the chain rule. But for some reason this book does things a little bit wonky, as you might have guessed by now. Okay, let's have everybody try part B. We'll work on part B on our own. We'll take about 2 or 3 minutes, and then we'll go through this problem together. Do you guys want the rule to be on the screen? How's that? Yes. Are there more than two functions?
Sorry. Is like ln separate from 2 plus 1? Like, should it be because it's being multiplied, or is that?
We're going to talk about it in a minute, so hold on to that question. Okay, can I have people raise your hand if you have finished the problem? Okay, a couple people still working. You guys want a little bit more time, or are you guys feeling a little bit stuck? Ready to move on? Okay. All right, so let's go through this together. So I kind of wrote down these rules, or this instruction set on the right-hand side here. First, we want to identify the functions being multiplied, then find their derivatives, and then kind of plug into this f prime g plus fg prime formula. Okay? So that's what we want to do here. So the first step is to identify the functions being multiplied. So the way I want to split it up is I want to write this as f of t times g of t, where I know how to do the derivatives of those things on their own. I need to know how to do the derivatives of them on their own because eventually I'll need them to plug in step 3. Okay, so last night when I taught this lecture for another section, I had a student say, well, I kind of think that the two functions being multiplied here are t cubed ln, and that function's being multiplied by the function t plus 1. Do you guys agree with that? I'm seeing a lot of heads shaking. Why is this not quite correct? Can anybody help put words to what's going on here? Yes, Emma?
Is the t plus 1 is like with the ln, like they're together, they can't be separated.
Very good. The t plus 1 and the ln cannot be separated. Okay, so I think that this student's confusion was stemming from the sort of rule that we tend to have in math, which, for example, in part C, if we come down and look at this problem, here, when we see these parentheses ending, what it really means is, okay, we just take whatever's inside the parentheses and then multiply times e to the x, right? So these parentheses mean sort of to multiply, right? We should distribute this e to the x. However, these parentheses that are in our problem are to show that this whole term is given by plugging t plus 1 into the function ln. So Emma's exactly right. We can't separate these things. So the way that we should split this up, well, let me ask you guys, what do you think are our functions that we should split it up as? Let's start with f of t and g of t, and then we'll work our way from there. What do we think f and g should be? You can give me either or both. Yeah, Mia?
F of t should be t cubed and g of t should be ln of t plus 1.
Very good. Okay, f of t should be t cubed and g of t should be ln of t plus 1. First of all, I agree with you. I think you're right. And now I want to address a question, which is it okay that g of t is kind of two functions here? It is okay, and here's why. What I wanted f and g to be are functions which I know how to do the derivative of. Doing the derivative of g of t will require the chain rule. However, in and of itself, it is a function which I know how to do the derivative of already. Okay, so it's okay that ln of t plus 1 is a little bit complicated. As long as we know how to do its derivative using our other rules, we're going to be okay. All right, so the next step. So we're moving on to step 2 now. We did step 1, and now we're going to do step 2. We're going to find the derivatives of these functions. So f prime of t, I won't bore you, should be 3t squared due to the power rule. And what about g prime of t? What do we think for that one? Ellie?
Sorry, 1 over t plus 1.
Yeah, 1 over t plus 1. This comes from the chain rule. And you can kind of think of there being an invisible times 1, right? Where that 1 came from the derivative of t plus 1. But we usually don't write it, just because multiplying by 1 doesn't actually change our function. So I'll erase it. It is 1 over t plus 1. Very good. Okay, so now we're gonna, I forget which colors I used. I think I used purple. Oh, I used purple and pink. Shoot. Okay. Well, okay. We'll just go on. So if I want to find out what's the derivative of f of g, oops, not f of g of x, f of x times g of x, well, it should be equal to f prime g plus f g prime. So I'm going to play the crisscross applesauce game. All right, so first up is f prime g. That's 3t squared. And I multiply that by regular g. That's ln of t plus 1. And then I'm going to add, and I'm going to do the other crisscross. I'm going to do f times g prime. So that gets me t cubed all over t plus 1. And that's going to be my answer. Yep. Make that t a little bit better. And that t is also kind of bad. All right. Yes, Ashlyn?
Sorry, how did you get 1 over t plus 1?
Great question. So, the question was, how, if g of t equals ln of t plus 1, why is g prime of t equal to 1 over t plus 1? The answer is that g of t is itself a composition of functions. We can write this as, I don't know, p of q of x, p of q of t, where q of t is the inner function, it's t plus 1, and p of z is the outer function, it is ln of z. So this is more chain rule stuff. So I compute the derivatives of those things. I get q prime of t is equal to 1, and I get p prime of z is equal to 1 over z. And I know that the derivative of g prime of t should be equal to p prime of q of t, where I leave the inside alone, and then I should multiply by q prime of t. Is this familiar? Okay, so this is from the chain rule which we did last time. And so now if I just take the information in my blue box and I plug into the formula here, I'll take q of t, regular q of t was t plus 1. I plug it in for z in p of z, which is ln of z. So I get, this part becomes ln of t plus 1. And then I have to multiply by q prime of t, but that's just 1. Ah, what have I done? Sorry. I should have plugged regular q of t into p prime. So it should be 1 over t plus 1. And then I should multiply by the derivative of q, which is 1. So that's how I kind of filled in the steps there.
Okay.
Any other questions on this product rule problem? All right. Geez, time flies. I only got 16 minutes. All right, I'm going to make a little bit of space here where I originally had my directions for product rule. That's where I'm going to actually do a problem. So I'm going to erase that. And we're going to learn the quotient rule. So what the quotient rule has to do with, quotient should remind you of the process of division, hopefully. And the way this is going to work is this is going to tell us how we do the derivative of f of x divided by g of x. Okay? So derivative of f of x divided by g of x. And you're not going to like it. It's a kind of ugly looking formula, and it goes like this. G of x times f prime of x minus f of x times g prime of x, all divided by g of x squared. Okay, so this is kind of a nasty formula. Here's a couple ways that people remember it. People sometimes call this low d high minus high d low, where low is representing this kind of lower function in our fraction, and high is representing the higher up one that's in the numerator. All over low squared. Sometimes that's how people remember it. I think there are some other mnemonic devices, but I don't know them. And one thing that I want to make extremely clear is, unlike the product rule, where if we switch up the order, we're still going to be okay, if we switch up the order of the numerator on the quotient rule, we're not going to be okay. Here's why. It's true that 6 plus 3 equals 9, and 3 plus 6 equals 9. So it doesn't really matter which order we do addition in. However, if we switch up the order of subtraction, we might get kind of messed up. For example, if we do 6 minus 3, we'll get 3. But if we do 3 minus 6, we're going to get negative 3. Okay? So order matters for quotient rule. Okay, we have to do g times f prime first. Okay. This might be the most complicated formula that you need to remember for the semester. I don't know. Maybe some people think the tangent line is a more complicated formula. I kind of think this is the most complicated one. Let's give it a shot of trying to put it to use. The first two steps are going to be exactly the same as the chain rule and the product rule. We first need to identify what are our functions which are being divided by one another. Then we're going to need to find the derivatives of those functions. And then it's just about plugging into this formula. Okay? So again, I'm going to change this letter F here to an H so that we can be a little bit more convenient for our notation. So I want to write this as f of, oops, that should be a t. F of t divided by g of t. So my question is, what is f of t and g of t? We want to write this as a quotient of two different functions. What should the functions be? Yes, Alice?
F of t be e to the 2t, and d to the is d.
Exactly right. Yeah, it's simpler than you might think. Whatever's on top, that's the top function, and whatever's on bottom, that's the bottom function. Okay, step 2, find their derivatives. I think we've already even done both of these derivatives today. F prime of t, that's going to be 2e to the 2t. We can use the e to the kx rule or chain rule to do that. To do g prime of t, that's pretty easy. We just use the power rule, or you could think of it as the linear function rule. It's just going to be the slope of that linear function, which is 1. So we have f and g and f prime and g prime, and now we just need to plug into our formula. I really gotta practice giving myself more space earlier on, because this is not doing me any favors to be, oh no. My G. Come back. Okay, G got big. All right. So now we just need to plug into the formula. We know we should do low D high minus high D low all over low squared. So what comes first? And it does matter that this comes first. Should have a fraction. H prime of T equals this fraction. And what comes first should be G, regular G, times derivative of F. Okay, regular G times derivative of F. So that's this direction. So we get 2t e to the 2t. 2t e to the 2t. So that was me multiplying G and F prime. Now I need a subtraction sign. And very importantly, on the right hand of the subtraction sign is where I need to put high D low. That's the other one. So high D low is going to be just e to the 2t. Okay. So now let's divide by low squared. Well, the bottom function is t. So if I plug that in and square that, I just get t squared. If I take the function t and I multiply it by the function t, I get the function t squared. Are there any questions about this problem? Or about the quotient rule? Does anybody have like a really good way of remembering the quotient rule that I don't know? Okay, that's fine. Okay, so that's how we do the quotient rule. So let's do one more example of the quotient rule. Let's have, oh, geez, I don't like that one. Let's do G. Okay, we're going to do G, and we'll have everybody practice it on their own first, and then we'll talk about it as a group. So we're doing the problem G here. Use any method that you like. I will tell you in advance that although quotient rule will work to do this problem, it's not completely necessary. Let you guys think about that for a while. Anybody want a little bit more time? Okay, we'll start. So first and foremost, did anybody not use the quotient rule? What rule did you use?
Can we use the chain rule?
You can use the chain rule. Let's do it with the quotient rule. And then after class, if you want to see how to never learn the quotient rule, I'll teach you. Okay, so let's do it using the quotient rule first. So if I want to write this as g of x divided by h of x, and oh god, I'm switching up the letters. Don't panic. Okay, we're still going to use the same format of this low d high minus high d low business, okay? All right. So what should g of x be? Yeah, just 1. The function 1, that's a function. And h of x?
1 plus e to the x.
Yeah, 1 plus e to the x, just the denominator. Okay, so step 2, let's compute these derivatives. G prime of x is one of the easiest derivatives. Maybe not the easiest. I think e to the x is the easiest. So second easiest derivative of a constant is 0. And then the derivative of h prime, we use the sum rule. Derivative of 1 should be just 0. And then we add the derivative of e to the x, which I think is the easiest derivative there is. It's just e to the x. Just rewrite it. Okay, so we have our stuff here, and as usual, I didn't leave enough space to actually do the problem, so I'm going to move that over. So f prime of x is going to be equal to some big fraction. And like the chain rule, I want you guys to focus on remembering the form as opposed to the specific letters which I used, okay? And when I gave it to you guys, I used F and G, but it could be M and N or S and T or W and U. Could be any letters that we want, okay? But what we need to keep is the form. So what should come first should be low d high. That means regular low function, multiply it by the derivative of the top function. So I get 1 plus e to the x times 0. And then I'll have a minus sign. Remember, order matters here. Now I need high d low. So start with our high function, that's 1, and multiply 1 times the derivative of the low function, which is just e to the x. So we get minus e to the x. And then the denominator will be, what should the denominator be?
1 plus e to the x squared.
Yeah, 1 plus e to the x all squared. That's the low squared part, okay? Regular low function and square it. Okay, so in the end, we wind up with negative e to the x over 1 plus e to the x squared. So that was our answer. And the last thing I'll say is that the clever thing that Alice did was to recognize that this can be written as 1 plus e to the x to the negative first power. So she was able to complete this problem by using nothing but the power rule and the chain rule. Okay. That's it for today. If you want to learn how to never learn the quotient rule, then stick around after class. It'll also be on the recording, so if you want to see that, you can see it on the recording. Yep. Have a good day. Looks like the usual suspects for staying after. Plus Jordan. Okay, great. Kyler, are you in a rush?
Oh, thank you.
No, I can chill.
Okay. I usually take a few minutes after class to go over a little bit of extra stuff, although I have to go soon because I have office hours. So I'll do this quickly. But here's how to never learn the quotient rule. And it's kind of a bad trick because really, if you want to learn this quotient rule, you have to have a really good understanding of the other rules. So it's not exactly a shortcut, okay? But here's how we do it. We say that the derivative of f divided by g, we can write this as the derivative of f, the function f, times the function g to the power -1. Do you guys see how that's the case? Because we can write f over g as f times 1 over g, right? So that's what's going on here. So if we have this thing on the right-hand side here, this is just a product of two functions. The left-hand function f, I know how to take the derivative of. And the right-hand function g, I also know how to do the derivative of using the chain rule. So what I can do here is I know that this is going to be equal to f prime times g to the -1st power plus, I'm going to leave f alone, and then I'm going to multiply by derivative of g to the -1st power. Okay? Rewriting a little bit, I'll get f prime over g plus f times, what should the derivative of g to the -1st power be? Remember, g is a function in and of itself. It's a chain rule problem. What's the inner function? Talking about this function right here. The inside function is just g. And g, the function g, is being plugged into another function. What is that other function? Could be something with z, maybe. Yeah, z to the -1 power. So I can write this as -1 times g to the -2, and then I should chain rule out the derivative of g. So let's clean it up a little bit. It looks like f prime over g plus f g prime over, sorry, this should be a minus sign, over g squared. Now, how would I get a common denominator between these two functions, or between these two terms here? If I wanted to combine these guys into one fraction, I have to have a common denominator. Which one has the more complicated denominator? G squared is more complicated. Is there a way we can change the denominator of this left-hand side to look like that? Yeah, multiply by g. If I multiply by g on the bottom, what do I have to do on the top? Multiply by g as well, right? So that I'm multiplying by 1. There's just a common denominator here. And so now what does this look like? Gf prime minus fg prime all over g squared. You might find that familiar. That's the quotient rule. So if you want to never learn how to do the quotient rule, and you're very familiar with how to use the chain rule and the product rule, then you don't have to learn it. Any questions about that? Yeah, I would say this is kind of a fun thing to do. I'm not sure that I would necessarily recommend that you use this instead of the quotient rule. It's probably going to be easier to just memorize it. But if you get stuck on an exam and you just can't remember which one came first, well, you can try to use this method to remember. Okay, that's it for today.